Hello everybody, I would like to present you a thesis named Robust Training of ADALINA based on the criterion of the maximum Correntropy in the presence of outliers and correlated noise, authored by Oleg Rudenko and Oleksandr Bezsonov. Let's start from the short introduction. ADALINA, or adaptive linear element, was the first linear neural network proposed by Widrow and Hoff and represented an alternative to the perceptron. Subsequently, this element and the algorithm for its training found a fairly wide application in problems of identification, control, filtering, etc. The Widrow-Hoff learning algorithm is a Kachmash algorithm for solving systems of linear algebraic equations. Properties of this algorithm for the solution of the identification problem are described in sufficient detail in the literature. The Kachmash or Widrow-Hoff regularized algorithm was used to train ADALINA in the problem of estimating non-stationary parameters. In this paper, a multi-step learning algorithm is considered, which is a recurrent regression analysis algorithm that accelerates the ADALINA learning process by using information not only about one last cycle, as in the Widrow-Hoff algorithm, but also about a number of previous cycles. Let's consider the task of the ADALINA training. ADALINA is described by the equation number 1, where yn plus 1 is observed output signal, xn plus 1 vector of the input signals with n by 1 dimension, and c is the vector of the required parameters, also n by 1 dimension. Theta is noise and n is discrete time. The task of its training, or ADALINA training, is to determine or estimate the vector of parameters c with star and is reduced to minimize some pre-selected quality functional or identification criterion that is numbered by 2, where E is output signal of the model, C is a vector that should be estimates C with star, and rho some differentiable loss function that satisfies the conditions 1, 2, 4. Correntropy, defined as a localized measure of similarity, has proven to be very effective for obtaining robust estimates due to the fact that it is less sensitive to outliers. For two random variables x and y, the correlation is defined as equation number 3, where k is rotation invariant Mercer kernels and sigma is kernel weights. The most widely used in calculating the correlation is Gaussian function defined by the formula 4. When calculating the correlation, it is necessary to know the joint distribution of random variables x and y, which are usually unknown. In practice, there is often a finite number of samples x, y. Therefore, the most simple estimate of the correlation is calculated as presented in formula 5. Consider the problem of training ADALINA described by equation 1, which in matrix form, after obtaining information on n plus 1 iteration, is written like presented at formula 6, where y with index n plus 1 is a vector of output signals, x with indexes n plus 1 transponated is matrix of input signals, c with star index with upper star index is a vector of estimated parameters, and also the noise is added here. The algorithm will have the form where the first two relations describe the inclusion of newly arrived information and the next ones describe the discarded or outdated information. is presented by formulas 7 to 10. If at first outdated information is discarded and then the newly received information is calculated, then the algorithm takes the form presented by formulas 11 to 14, and also some additional formulas are described with number 15. Very important topic is selection of sigma parameter. So the following correlation scheme is proposed for sigma squared selection and is presented by formula 16. It should be noted that terms 1 and 2 can be considered as compensation for estimating E or error of identification. To reduce the computational load, this expression can be simplified as described by formula 17. Analysis of the above approaches to parameter selection, sigma parameter selection, shows that there is no single rule for choosing this parameter. Therefore, in the practical implementation of algorithms based on maximizing the correlation, one should be guided by the recommendations discussed above. So to conclude, in this work the main relations that describe an adaptive multi-step algorithm for trading ADALINA are obtained, which allows to adjust its parameters in real time in the presence of outliers and correlated noise. The use of such an algorithm accelerates the learning process by using information not only about the last cycle, as in the traditional Wydrow-Hoff learning algorithm, but also about a number of previous cycles. The robustness of the estimates is ensured by the application of the maximum correlation criterion. Thank you for your attention. I hope this thesis was useful for you. Thank you very much.